Okay, so to start off with, we have a couple pieces of important information, a couple pieces of important vocabulary that we need to understand to make some sense of today's lesson. What does it mean for something to be quadratic?
Has like four
No, that was
sides.
polynomial. Quadrilateral means four sides. Remember when we talked about polynomials? Polynomial was four or more terms. Quadratic had to do with the exponent. Do you remember which one quadratic was? Squared, x squared. So a quadratic function is, let's just say a function, function, what is wrong with my pen? My pen's messed up. Function, there we go. With highest exponent of 2, right? So the highest exponent of 2. What is the standard form of a quadratic function? Do you remember that? So the thing that had the a, b, and c in it?
Oh, it would be exponent, like the one with the exponent, then it would be just x, and then nothing else.
Yeah, so it's always y equals ax squared plus bx plus c. And a, b, and c will all be numbers. But that's just important because we need to know that because later on we'll have to identify what's a, b, and c, especially moving forward. A parabola, does anybody know what a parabola is? Parabola.
It's not like a type of bread.
No. Anybody? What knows? That's what you call the graph of a quadratic. Okay, so a parabola, I'll just draw a picture for that one. Parabola looks something like this. Or it could open downward if it looks like that. Those are parabolas. Okay, so that's what the graph of a quadratic looks like. It's called a parabola. You could say it has parabolic shape. Okay, and then the last thing that we need to know is what a vertex of a parabola is. Okay, the vertex is either the, we'll just do a quick, it's probably not the technical definition, but a quick kind of working definition is just the max or min. So depending on if it opens up or down, it could be the maximum or minimum. So the vertex, like on where I drew the parabola pictures, if I have this parabola that opens up here, it would be this minimum point right down here. That would be the vertex. Or if I have this parabola that kind of opens downward, it would be this maximum point up here where it shifts from going higher to lower. Okay, so that's kind of the vertex. So let's kind of make some sense of what we have been doing with the factoring stuff. And kind of moving forward now, we need to learn how to graph these nonlinear equations, these quadratic equations, okay? So that's kind of what we're working towards here. So do I have somebody that would like to read this paragraph for us up here at the top? Anybody?
Oh, I got it.
All right, Sam.
Wait, that one, yeah, right?
Yep.
Alright, wait, yeah. Carter, Alicia, and Joseph are building a trebuchet?
It's a trebuchet.
Trebuchet.
Yeah, that's okay.
A type of catapult.
Yep.
For an engineering competition. A trebuchet is a medieval
Siege weapon.
siege weapon that uses gravity to launch an object through the air. When the counterweight at one end of the... Wait, did I skip for one?
Yeah, no.
No. When the counterweight at one end of the throwing arm drops, the other end rises and the projectile is launched through the air. The path the projectile takes through the air is modeled by a parabola, right?
Mm-hmm.
Yeah. To win the competition, the team must build their trebuchet according to the competition specifications to launch a small projectile as far as possible. After conducting experiments that varied the projectile's mass and the launch angle, the team discovered that the ball they were launching followed the path given by the quadratic equation.
Okay, you don't have to read it. So there's our quadratic equation, okay, which you can see is in standard form, right? Here's our quadratic equation. And then it also gives us a graphical representation. So here is the graph for that quadratic equation. Okay. Today we are going to learn about specific parts of the graph that we can find from a quadratic equation like this to work towards being able to graph these. Okay. We're gonna just focus on trying to find them today. Next class, we're gonna put it all together as far as actually graphing them, and we'll look at some special cases. Okay. So I want you guys to start off by answering. So using this graph, I want you to answer 1 and 2 on this page, and I want you to answer 3 and 4 at the top of the next page. So together with your groups, I want you guys to answer 1, 2, 3, and 4. Go ahead. Okay, so number 1, how far does the ball land from the launching point?
16.
Yeah, 16 meters. How do you know that? Okay, so I pay attention to the labels on the graph, right? This one over here is height. So up and down is obviously the height. This would be the distance that it traveled. So it gets shot up in the air, reaches top height, and then comes back down and lands at 16, right? So 16 meters. Circle the points on the graph where the ball's on the ground. Well, we obviously know it landed at 16 meters. What's the other point that it's on the ground? 0. It'd be 0, right? And that would be where it was launched. So then 3 wants me to label the coordinates of that point. So what were the coordinates that the ball was on the ground? What was the launching point? What was the coordinates of that? 0, 0, right? Over none and up none. What was the coordinate of the landing point?
Yeah.
16, be 16, 0, right? Because it went out 16 meters, and obviously it's 0 meters off the ground, so the 0 is at the second spot. Okay? Then number 4 says solve the projectile path equation right there. So it gave me this function that was negative 1/8 x squared plus 2x equals y, right? That's what it gave me on the last page. How did we go from that to now solving it? No. You guys are missing my question here. How do I go from the equation that they gave us on the last page to now this equation that I'm supposed to solve? Okay, so the y turned into a 0. That is a super important point, okay, that you guys have to understand. You have to understand that anytime I'm solving for solutions or trying to find zeros, we'll talk about the different names for it in a second, that means y is 0. So I plug a 0 in for y, and then I have to do something else. So in this specific case, since we have this fraction, I told you to multiply so that you no longer have a fraction. What would I multiply by here to get rid of my fraction? 8, because that's the denominator, right? So if I zoom in here on number 4, I multiply every piece by 8. Negative 1/8 times 8 is just negative 1x squared. 2x times 8 is plus 16x equals 0. So I plug a 0 in for y. Now how do I solve this? You guys know how to solve stuff with x squareds in it?
You just do it twice. You do it like C.
Okay, so I'm starting to look at factoring methods, right? That's the only way that I know how to solve something with an x squared in it right now. What is the factoring method that I should always try first? GCF. Is there one here? Yeah, I can take an x out. So if I take an x out, I'm left with negative x plus 16. And there's no other factoring that needs to be done because I have no more x squareds, right? So I factor out an x, and now I'm ready to solve. So my two chunks, remember, in order for this whole thing to be 0, either piece can be 0. So I can set up one equation that is x equals 0. That one's already solved for me. And then I set up my second equation, negative x plus 16 equals 0. So I subtract 16 from both sides, I get negative x equals negative 16. I divide by negative 1 on both sides, and I get x equals positive 16. So how do I find the solutions to a quadratic? Factor and solve. Okay? So I find the solutions to a quadratic by factoring and solving. Later on in this unit, we will learn other ways to solve a quadratic. Right now, the one way you know is factor and solve. So that's what you're going to do for all of them, okay? So anytime I ask you for solutions, you know you should factor and solve. Are these solutions significant to our problem, x equals 0 and x equals 16?
Yes.
They were, what were those points?
Points that the ball.
The points where they were on the ground, right? So we have several names for these specific points because this is very, very, very important for me to understand, okay? Or these points are very, very, very important for me to be able to find and for me to be able to apply. Okay? So let's look at the different names for it. So you saw on the graph, the points where the ball was on the ground, those were both the points where the line crossed what? If you have to scroll back up and look, that's fine. The 2 points where the ball was on the ground were the 2 points where the line crossed the x-axis. We call the points where the line crosses the x-axis, we call those what? X-intercepts, right? So those numbers can be called the x-intercepts of the graph. They're also called just what we saw there, the solutions to a quadratic equation. So we could call them x-intercepts, we could call them solutions, we could call them real roots. That's probably the word that you hear the least. So I'm not necessarily that worried about that one, but it could be the real roots. Or probably the most common name for them are the zeros of the function. Why do you think we call them zeros? They're the beginning and end, but what's true about the beginning and end points? What's significant about the x-axis? Why would we call them zeros? What is 0 at those points? Think about the coordinates. Think about the coordinates that we wrote. What was 0 about the coordinates that we wrote? Up on number 3. The what? The y. That's why we call them zeros, okay? So zeros, we call them zeros because y is 0. So anytime it asks you to find solutions, you should automatically think I need to plug a 0 in for y, factor and solve. So I want you guys to do 7 and 8 together with your partners. Do 7 and 8 together with your partners. Go ahead. Or no, 7 and 9. Sorry. Do 7 and 9 together with your partners. Go ahead. Okay, guys, so here's 7. Remember, finding zeros, I plug a 0 in for y, and then just factor and solve. So my factoring method here was just taking out a GCF. You can see I took out a GCF of 3x, and I was left with x minus 2. So in order for this whole thing to be 0, either this piece could be 0, so 3x equals 0, divide by 3 and x is 0, or x minus 2 equals 0, so add 2 to both sides and x equals positive 2. So if I were to make a quick sketch of this graph, okay, in a second we will learn about vertex, but for now, since we don't know vertex, we're just going to say, okay, so I have x equals 0 right here. That's one of my x-intercepts, or my zeros. X equals 2, I would go over 2 on the x-axis, or on the x-axis, there's x equals 2. So those are my 2 zeros. Every time I find the zeros, those are my points that cross the x-axis. I would find, and we don't know how to do this, but I would find the vertex somewhere around here. And there's my parabola, okay? So we'll get more specific when we are able to find the specific vertex. But for now, we see the zeros and we can sketch a quick graph for our parabola. They always either open up or down. They never open sideways or like diagonally or something like that. Okay? All right, and then let's look at 9. So factoring method was AC here, right? Because I have 3 terms. It's already set equal to 0 for you, and it just asks you to find the solutions. So I'm just factoring. Find the 2 factors that multiply to 5x squared, that add to negative 6x. Break it apart, group, all that fun stuff. Make sure you solve at the end, and I get x equals 1 and x equals 5. So if I wanted to make a quick graph, x equals 1, there's 1, 0, 2, 3, 4, 5, there's my other 0. Find my vertex somewhere here in the middle. And there's my parabola, my quick sketch of my parabola. Okay? So right now we are just able to find these points right here. Okay, these these 0 points. Any questions so far? Okay, can I get a comfort level on finding zeros or solutions or x-intercepts?
2.5.
Okay. All right, so practice makes perfect. We'll keep practicing. We'll be okay. All right? All right, now let's move on to looking at vertex. So first it asked us on number 10, the graph of the function y equals x squared minus 6x plus 5, which is the same one that you just solved on number 9, is shown to the right. Do the x-intercepts of the graph match which we found in number 9? They do, right? The x-intercepts or zeros or solutions are 1 and 5. X equals 1 and x equals 5. So now let's start looking at vertex. I want you to answer 11 and 12 together with your partners. Go ahead with 11 and 12 together with your partners. Okay, so 11, put an X where the vertex is located. And can somebody remind me what's the vertex again? The maximum, right? The lowest or highest point. In this case, since our parabola is opening up, it would be the lowest point, right? And it's this lowest point right down here. So there's my X on my vertex. What are the coordinates of that vertex?
3, -4.
Yeah, over 3, down 4. So 3, -4. So that X coordinate of the vertex is 3. Did anybody notice a relationship between that 3, that X coordinate of the vertex, and the 2 zeros?
It's exactly in the middle.
It's exactly in the middle. Okay? That is super important. Okay, and it's important to realize that, and that's always going to be the case. So let's just write that down here. So the X value of the vertex is always the exact middle of the zeros. And remember, zeros and x-intercepts and solutions are all the same thing. So that vertex will always split the middle between the 2 zeros. It'll obviously be up or down something. That's what makes it nonlinear. But it'll always split the middle of those 2 x-intercepts or solutions or zeros. Okay? Okay, now let's actually look at how to find the vertex. And I think you guys are going to like it because of one little word. So on the next page up at the top, it says the x-coordinate of the vertex can be found by using the, what's the next word?
Formula.
Formula. I know you guys always like formulas. You don't like formulas? Usually kids like formulas because you don't have to remember anything, right? You just kind of plug numbers into something and then you do it.
Oh, good.
Okay. So there is a formula. So, sorry, can you remind me, how do we find zeros? How do you find zeros? Factor and solve, right? So you find zeros by factor and solve. You have to make the y 0 and then factor and solve, right? How do we find vertex? Tells you right there. Using the formula, okay? So you might want to circle, star, underline, highlight, put a cloud bubble, tweet it to your best friends. I don't care what you do. You need to remember that formula for the vertex. You know you want to tweet the vertex formula.
You just wait.
Think about how quickly you would trend on Twitter.
I'm doing it.
Jeez. Or is it more of an Instagram thing because it's a picture?
Nah, you can.
You can take a picture of it.
I'm doing it right now.
Cool. Make sure you tag me. NHS_Craw. Okay, anyways. All right, so that only gives me the x value of the vertex, right? A vertex is a point, an ordered pair, an x comma y ordered pair. So I have the x value of the vertex there, and then I just plug it back into my formula to find the y part of the vertex. So let's look at one together. Let's look at 14. So my formula here, and I'll just write it up above 14, remember, was x equals negative b over 2a. So it's important for me to know what a and b are before I find my vertex. You guys remember how to identify which one's a and which one's b and which one's c?
Yeah.
Okay, a is always where?
First.
No.
No.
Wrong.
Wrong.
A is always where?
First.
No. Wrong.
Wrong.
A is always where? With the x squared. B is always where? With the x. Don't say first, second, third, because sometimes they might not be in order. Okay? A is always next to the x squared. B is always next to the x. So what is B here? Negative 6. So I have x equals negative b. So if b is negative 6, what's negative b? Positive 6, right? Because it's a negative 6. So I'm going to do plus a positive 6 over 2 times a. And what's a here? Yeah, the number in front of x squared would just be 1. Make sure you don't take the variables with it, though. I hear you guys saying x is an x squared. It's an imaginary 1 in front of x squared right here, right? So that's my a. So what's 6 divided by 2? 3. So that's the x value of my vertex. That's not my vertex. That's only the x value of my vertex. I need to plug it back in to find the y value. So I use my function, y equals x squared, and I know what x is now, so 3 squared minus 6 times the x was 3 plus 5. You see what I did there? I just took my function, plugged in my x value into both the x spots, and now I can solve for y. So what's 3 squared? 9. Negative 6 times 3 is negative 18. And then plus 5. So what's 9 minus 18? Negative 9. Negative 9 plus 5 is negative 4. So y equals negative 4. So what is my vertex?
3, negative 4.
3, negative 4. It's always x comma y. So 3, negative 4. Okay? So that's how you find your vertex. Use your formula for x, then plug the x value back in to find your y. Remember, a vertex is always an ordered pair. All right. You guys try 15 with your partners. So try 15 with your partners. Go ahead. So my formula is x equals negative b. What is b here? It's a number in front of x. So it's 2 over 2 times a. What's a? 1. So 2 times 1 on bottom is just 2. Negative 2 divided by 2 is negative 1. So I found an x value of negative 1. Okay, now I need to plug it into my function to find y. So y equals, I have negative 1 squared plus 2 times negative 1 minus 8. So I plug in my negative 1, now I can solve for y. So negative 1 squared is negative 1 times negative 1, that's positive 1. 2 times negative 1 is minus 2, minus 8. 1 minus 2 is negative 1. Minus 8 would be negative 9. So I have y equals negative 9. So what is my vertex? Good. Negative 1, negative 9, right? Always x comma y. Okay, do we have any questions?
I actually got this one. Sydney.
What are you confused about?
I think I get it. I multiplied instead of
Wait, where'd you get it?
I've redone the problem like 20 times because first I forgot to put negative.
Okay.
Oh.
So just be careful with your formula. Okay, so let's do one of these problems all the way together, okay? Because we're putting it all together and it's going to be on your homework that way, and I don't want you guys to be freaked out by it. Okay? So just find some open space. You can add an extra page to Notability if you want to. I'm just going to go down here at the bottom. Okay, let's do this. So I want you to find the vertex and zeros. Okay, we're going to skip axis of symmetry for now. So I want you to find the vertex and zeros, and we're going to use this function y equals x squared minus 5x minus 14. So what I always want to see you do on a problem like this is break up your workspace in half. Half is going to be for the vertex. Half is going to be for the zeros. Okay? Because we do have to do both for each problem. That's the only way you can graph it is if you have both zeros and you have a vertex. Okay? So let's start with vertex. How do I find vertex? The formula, right? So it's x equals negative b over 2a. Okay, so always remember your vertex, you're using the formula. So, what is a here? If you need to, write them down. What is a? 1. The imaginary 1 that's in front of x squared. What's b?
5.
Negative 5. It's the negative 5 that's sitting in front of the x. So x equals negative 5. So that's going to turn into a plus 5 on top over 2 times a, we just said is 1. So 5 divided by 2. And on a vertex, guys, decimals are probably pretty appropriate. Okay? So 5 divided by 2 is just going to give us 2.5 for my x value. But remember, a vertex is an ordered pair, so I need to plug that back in to find y. So y equals 2.5 squared minus 5 times 2.5 minus 14. So 2.5 squared is 6.25. Negative 5 times 2.5 would be negative 12.5. Then I have minus 14. So 6.25 minus 12.5 would be negative 6.25. And then minus 14 more would be y equals negative 20.25. So that's all the work I go through to find my vertex. So I'm just going to pull it up here a little bit. So what is my vertex? 2.5 comma negative 20.25. Okay, that's only half of my answer though, right? Because that's only the vertex part. I still need to find zeros. How do I find zeros?
You factor and solve.
You factor and solve. What do I have to do before I can factor and solve? What does zeros mean?
You're gonna change the y to the 0.
Yeah, y equals 0, right? That's what zeros mean. So zeros means y equals 0. And then I know I'm going to factor and solve. Okay? So I plug a 0 in for y, so I have 0 equals x squared minus 5x minus 14. What is my factoring method I should use here? AC, right? So negative 14x squared. That adds to negative 5x would be 2x and negative 7x. So I have x squared plus 2x minus 7x minus 14. Out of the first two, I pull out an x, and I'm left with x plus 2. Out of the last two, I bring out, oops, I keep putting that parenthesis too early. Out of the last two, I bring out a negative 7, and I'm left with x plus 2. So x plus 2 comes out, and x minus 7 is left over. And the equal 0 part tells me to solve, right? So I'm done with the factoring part. Now I need to solve. So I have x plus 2 could be 0. Or x minus 7 could be 0. So I solve both of those and I get x equals negative 2 and x equals positive 7. So here's my complete answer. Vertex and zeros. Now I could very, very easily graph that, right?
Yeah.
Stick my zeros on my x-axis, graph that ordered pair for your vertex, and then you have your 3 points to make your parabola. Okay?
Yep.
I know it seems like a lot of work, but just take it step by step, right? Do your vertex, you use the formula, then plug it back in. Your zeros, don't forget, you already know how to do all that, right?
Yeah.
You already know how to do all that. Just find your factors, break it apart, group, solve. You know how to do all that, okay?
Yeah.
All right, the rest of the time is yours for homework.